walk in. All right, so today we're doing 1.3, the 12 basic functions. Here we go. What we're going to be doing is all of these functions, all 12 of them, that is what the basis of this class is all about, exploring each one of these. It really is. Okay, the first one, identity. That is f of x equals x. Okay, it is basically a linear function. Where does this graph pass through the y-axis at? What do you think? I mean,
0.
0, yeah. Okay, and what's its slope?
1/1.
It's just 1, and so it goes like this. It just goes straight on through. Okay? It's got a slope of 1. It actually makes a 45-degree angle there, and that is it right there. Okay? If we had to talk about it, what do you think its domain is? Yeah, negative infinity to infinity. There's no breaks in here. There's no bumps or jumps or anything. What do you think its range is? Same. You know, I mean, all y values work, all x values work, and it goes just like that. Okay? This is a very simplistic function. It works in all areas. Okay? All right, the next one is a squaring function. I'm recording this. Okay. The next one's squaring. Again, that looks like this. F of x equals x squared. Sometimes it's called a quadratic. Okay? Anybody remember the shape of it? Horseshoe, parabola. Okay? And on the back wall here, I do have all 12 of these functions. Created other years, but that's what we have. Now, if we had to examine this one, what do you think the domain of this one is? What x values will work? What can I put in there? Yep, same thing. Negative infinity to infinity. You got it. Now, range is a little different. What do you think about the range there? 0. Does it include 0? No. If I put 0 in for x, will y be 0? Yeah. Yes. So it actually includes that point. So when you write the range down, we need a bracket showing that it is included. Okay? There we go. Okay. Do you remember last chapter we talked about things like symmetry, asymptotes, and all that other stuff? Or the last section? We are going to be talking about these 12 functions and all of that after we go through them. Okay? Cubing function. And again, we're talking about the most basic cubing function. That's going to be f of x equals x cubed. It's going to come in, and it's going to go like that. Okay? All right. Looks pretty good. What about, go ahead. Yeah, what is our domain on this guy? Yes, it is. It is, in fact, all of them. Okay? It doesn't look like it, but this graph will eventually keep going all the way out as it does this way also. Okay, it will keep going. What about the range in this case? What y values will work?
Same.
All of them, that's right. Negative infinity to infinity. Okay? All right. And again, we're learning just the basic functions. In the next couple of chapters, we're going to, add things to the cubic function to move it, shift it, transform it. But for right now, this is it. All right. Are we set on that? Okay. Okay, the next one that we're going to talk about is the reciprocal function. All right? The reciprocal function, when you think of reciprocal, what do you think of? When have we used that word reciprocal?
Perpendicular.
Okay, we do use reciprocal when we talk about perpendicular lines, but what about the perpendicular lines do we use the reciprocal on?
Slope.
The slope. And so we use it, and what does reciprocal mean to do? You what?
The negative.
You flip it, and what type of a number do we flip typically? A fraction. And so that is what this function is. It's the 1 over x. It's like the fraction function. Okay? All right. Now on this one, what can x not be? 0. There's an asymptote there. Okay? So it comes like this. this function has two branches. And they come in like that. All right? They're supposed to be symmetric. I didn't draw them real symmetrically. Okay? What is our domain of this function? What's the domain here? What? Yes, negative infinity, and then what happens is at 0, we have to lift up the pencil and jump over. So then, yes, we put the little union in there, and then it is then from 0 to infinity. There we go. And what about the range? Exact same thing, because with going up the y's like this, in order to get to the next graph, we have to jump over that part right there. So it is the same. Okay? All right. Now, next one.
What is that?
That is a cart outside. It's got squeaky wheels. Okay, the next one is the square root function. Okay? Square root function looks just like that. Square root of x. All right, now, if we took this function right here, I'm just going to go over here for a second and replace the f with a y. Okay, I'm just going to go over here for a second. How do you get rid of a square root?
Square it.
Okay, so that would give me y squared equals x. We had one of these in our homework. Do you remember what it looked like? Do you remember what this one looked like, you guys? Y squared equals x.
No.
Do you know what the x squared function looks like? It's a parabola. There you go, that's right. And so y squared is just a sideways parabola like this. Okay? But this particular function is only, do you see how it's positive? It's only the top half of the parabola. Okay? Because when you take the square root of a number, it is typically, if I took the square root now of both sides, it would be y equals plus and minus the square root of x. The square root function only graphs the top half of the parabola.
Whoa.
If you want to get both halves graphed on your calculator, you have to actually enter in two functions. Y equals the square root of x and y equals the negative square root of x to get the bottom branch. Okay? Now, so, because that gives us some restrictions, what is the domain on this?
Does it touch 0?
Oh, that's a good point. Does it touch 0 there?
Yes.
Yes, it does. So that should be a bracket.
Yeah.
So it's bracket 0 to.
Keep going.
Yes, it does. Infinity. And what about the range then?
0 to infinity.
That's right. Same thing. 0 to infinity. Okay?
Is it always the same?
No, sometimes they're different depending on what they look like. Okay? All right, my next function is my exponential function. Okay? And if you've ever heard the term that something grew exponentially, that means it grows really fast. The one that we're going to talk about is y equals e to the x.
Wait, why not f of x?
Oh, you're right. I should have done f of x. I'm sorry.
Is there really any difference?
No, they're interchangeable. The only reason that I'm actually writing them with the f right now is because I want you to know that we're talking about a function, and the variable in the function is the letter x. That's the only reason. Okay? Now, the e to the x function, okay, it starts off really slow. It goes through 1 right here.
Always.
Yep, it always goes through 1, and then it grows and grows, and then it grows really fast. Okay? A good example of that would be I don't know if you remember this from Algebra 2, you have a choice. I could give you $10,000, or I can start you off, it's $10,000 for the month, or I can start you off with a penny on day 1 of the month, and then I would double it every day. What would you take?
The way to go.
The penny is the way to grow. It will start off growing really slow, but then it will shoot way up there once it's doubled enough. Okay? All right, so taking a look at this graph, what does the domain, what x's work on this graph? All of them, exactly. So negative infinity to infinity. Okay? And what about the range then?
0.
Now, okay, and so we got to decide, will this graph touch 0?
Never.
Never, no. No, there's an asymptote there. So it's 0 to infinity. That is correct. Okay? All right. Are you all set? Okay. All right, we've got 6 more to go. All right, now what we have is the natural logarithm. There's common logs and natural logs.
Wow.
And we go over the natural log one. Okay, that's an L and an N. Small l, small n. All right? And that's how it's written. It's written just like that. Okay? And now the natural logarithm is actually the inverse of an exponential. So it starts down here, comes up through 1, and climbs like that.
What the heck is that thing?
This is a natural logarithm. That's how it grows.
What is that above it?
This is the notation. Do you know how log is written like this?
It's gonna be out and out.
Okay, this is just ln. Yep, I made it cursive, sorry. If you take the two graphs and look at them,
Exponential sideways.
exponential goes like that, okay? And if you folded the paper along the y equals x line, do you see how they would match up? That's why a natural log and inverse logs, they're inverses of each other. Okay? All right, what is the domain then? What x values work?
0.
Okay, now I want you to notice something else. Okay, and what is the range then? Negative infinity to infinity. Okay, because these are inverses of each other, inverse functions, the x values and the y values switch. Look at the domain and the range. They just are switched. So they're exactly the same except they're switched. And this works because the exponential function is an inverse of the natural log function. Okay?